Hi students, this is Ms. Tai here. In this video, you will learn 5 questions that will get you ready for the new digital SAT. Grab a notebook and pencil and let's get started. What is 10% of 570? Let's look at our quick tip. When in a word problem, the word of typically translates to the multiplication operation. So you can use the algebraic method or the proportion method to solve. Let's start off with the algebraic method. We have what is 10%? 10% can translate into the fraction 10 over 100, and of translates to multiplication. So 10 over 100 times 570. Let's cancel out the zeros that we don't need. 10 over 100 will simplify to 1/10 because we can divide both the numerator and denominator by 10. We also can divide both 570 and the number 10 by 10. So these zeros will also cancel out. 570 divided by 10 is 57, and 10 divided by 10 is 1. So we are left with 1 times 57 is 57, and 1 times, technically this has a denominator of 1, equals 1. So our final answer here is 57. This is the algebraic way to solve this problem. So we can see that B is the correct answer. I'd also like to show you the proportion method. When solving a percent word problem using the proportion method, we typically use this formula. We say is over of equals the percent over 100. We have what is. So the word what is going to translate to X because we don't know what that number is. So what is? So X has to relate to the is word. We will replace is with X, okay? And then 570 is going to replace the of word. So X is our part and also our unknown variable, and 570 is the total. We have X over 570 equals the percent, which is 10 over 100. Now we can cross multiply. When solving a proportion, you're going to have 2 equivalent fractions, and you can go ahead and cross multiply. When we cross multiply, we have 100x equals 5,700. Our final step is to divide both sides by 100. When we divide the left-hand side by 100, 100 divided by 100 completely cancels out. And 5,700 divided by 100, these zeros are going to cancel out. So we are left with x equals 57. Notice we got the same exact answer, so we know for sure that B is the correct answer. Let's continue. Which equation has the same solution as the given equation? When solving problems like this for the SAT, they're really trying to figure out if you understand how to apply the order of operations method and the inverse operations method to solve. So let's start off by solving our equation. So we have 6x plus 8 equals 26. In order to isolate the variable x, our first step is to apply the inverse operation here. The opposite of adding 8 is to subtract 8. We will subtract 8 on both sides. 8 minus 8 cancels out. 26 minus 8 is going to give us 18, okay? So we have 6x equals 18. Now, some students might have made the mistake, and instead of subtracting 8 on both sides, they would have added 8 on both sides, which is totally incorrect. If we add 8, we would have 26 plus 8, which is 34. That would be the incorrect answer. So you can see they actually put one of those mistakes right here in the answer choices. Another mistake might have been to multiply 26 times 8, because we see that 6 is being multiplied by x. So maybe a student might have said, hey, let's just multiply these two numbers. That's where you would get 6x equals 208. That is also incorrect. So I want you guys to be very aware of what the most common mistakes are, because that's going to be baked into the incorrect choices on the SAT. The test writers are very good at understanding what are the most common mistakes that students make, and that's how they come up with these answer choices. So be mindful of that. So notice, since 6x equals 18 is actually the next step in our problem, it's going to yield an equivalent solution. So C is definitely the correct answer. Now, if you're wondering, where did they get 6x equals 3? My thinking is they went ahead and solved the problem, and notice that x was equal to 3 and might have made the mistake and said 6x equals 3 instead of x equals 3. So D is also incorrect. Make sure you're mindful of these steps when solving a two-step equation or even beyond. There are going to be some multi-step equations on there as well. So you always want to undo the addition and subtraction bonds first, and then undo the multiplication and division bonds second. And take a look as you're solving to see which one of these equations matches one of your steps. Let's continue. The total cost in dollars to rent a lane at a bowling alley consists of a $25 service fee and a $10 per hour rental fee. A person rents a bowling lane for T hours and intends to spend a maximum of $75 to rent the bowling lane. Which inequality represents this situation? If we're going to have a maximum of $75, we know for sure that the total amount needs to be less than or equal to $75. It looks like all of our answer choices have this information at the end of the inequality. So far, we can't really eliminate any of the answers. We also know that there is a service fee. So this is almost like a y-intercept or a one-time fee or a starting point. When representing a linear inequality, the starting point is typically a constant. So that number 25 will not have a variable attached to it because the person is only going to pay it one time. So if you just take a quick glance, I only see one answer choice that has 25 represented as a constant with no variable attached. So it's looking like D is the correct answer. But let's confirm. We also have a $10 per hour rental fee. So each hour, they're going to pay $10. So that's where we're going to have the variable attached because we're going to take T and multiply it by 10. So we have $25, which is our one-time service fee, and then $10 times the number of hours. So 25 plus 10T is less than or equal to 75. So of course, D is the correct answer. The function m is defined by m of x equals x cubed minus 2. For which value of x is m of x equal to 25? Remember, when evaluating a function, the x value is always the input value and the y value is your output value. So notice if m of x equals 25, we know that 25 is going to be the output value, or in other words, like the y value, right? The thing that comes out of the function machine. We don't know the x value, right? So we don't know our input. So we can set up our equation. Since x is unknown, we have x cubed minus 2 equals our output value, which is going to be 25. So now we actually have an equation that we can solve. We're going to perform the inverse operation by adding 2 to both sides. We now have x cubed equals 27. And then we're going to find the inverse of cubing something, right? The opposite of cubing something is to find the cube root. So I will find the cube root of both sides of this equation. The cube root of 27 equals 3. So we can see that x is equal to 3. So B is the correct answer. Each face of a fair 14-sided die is labeled with a number from 1 through 14 with a different number appearing on each face. If the die is rolled one time, what's the probability of rolling a prime number? Now, I hope you guys remember your prime numbers. I'm going to go ahead and write out the numbers 1 through 14 so we can discuss which numbers are prime. We have the numbers 1 through 14. Let's identify which of these numbers are prime. One of the biggest mistakes that students make is they think that 1 is a prime number. But guys, you need to remember that 1 is not a prime number. It's also not a composite number. So that could be one of the mistakes that some of our students will make while taking a digital SAT. So keep this in mind. We don't want to include 1 as one of the prime numbers. But for sure, we know that 2 is the first prime number. 3 is definitely prime, right? 5 is prime. 7 is also prime, right? We're looking for all the numbers that have only 2 factors, 1 and itself. So 2 is 1 times 2, 3 is 1 times 3, 5 is 1 times 5, 7 is 1 times 7, right? Let's kind of talk about why 6 is not prime, right? Because 6 is going to be 1 times 6 and 2 times 3. So it has more than 2 factors. All right, 8 is going to be 1 times 8 and 2 times 4, more than 2 factors. 9 is going to be 1 times 9, but also 3 times 3, also more than 2 factors. So 9 is composite. So the next prime number is 11, and then of course 13. So when we calculate the probability of an event, it's going to be the number of successes, right, divided by the total outcomes. So how many numbers are prime? How many prime numbers can we choose from here? We have 1, 2, 3, 4, 5, 6. So that's the number of successes, like which numbers are actually prime. When we roll a die, that's numbered from 1 through 14. And then the total possible outcomes is 14 because it can land on any one of those 14 faces of the die. So the correct answer is 6 out of 14. Now, I know that some students may have included the 1, so this probably would have been the second most occurring answer, 7 out of 14, but it would be incorrect. So please be careful. 1 is not a prime number. It never has been. It never will be. So write that down really big in your notes so that you do not make that mistake. If you learned something in this video, please go ahead and like, comment, share, and subscribe, and I'll see you in the next video.